Well, hello again. Welcome to Lesson 9, Direct versus Partial Variation. Now, what I like to do is always combine English, as in English class, with math, because a lot of the time, math is just another language. And it could be, a lot of the words are interchangeable between English class and math class. Here's a perfect example of it. Direct variation versus partial variation. When you think of the word direct, what does that make you think of? Direct makes you think of an immediate relation. Okay, so with that being said, to fill in the blank here, in the two graphs here, one represents direct and one represents partial. Now your job is to identify which is which. Blank variation is when the graph is a straight line that passes through the origin. Okay, so there's no funny business going on. It's just a direct. I guess I just kind of told you the answer there, but a direct variation. Now I want you to draw an example there, and what I also want you to answer is, well, what is the initial value of the graph? And what I mean by that is, looking on the y-axis, where does it start? Same thing with this graph. Once you draw an example, tell me where your line started. Okay? For question 2. For the following questions, state the rate of change and the initial value. Okay? So all I want you to do is identify what is changing, okay, and where is it starting. I'll do the first one for you. Bell Canada charges $20 per month plus 10 cents per minute for long distance calling. It must be a house phone because no cell phone is that cheap. So which number is changing? Is it, now we are talking about per month bill. So if you have a cell phone, you know you pay once a month. Okay, so per month they charge $20 plus 10 cents per minute. Given that, we know that this changes based on how often you use your phone, how many minutes you use your phone. Okay? Which means that is the rate of change. That is what is changing. Therefore, the rate of change is, so rate of change is equal to per minute. Okay? Now the other part of the question is asking for the initial value. So even if you have a contract with Bell for your cell phone and you don't ever use it, you leave it at home collecting dust. You give it to your little sister, little brother, whatever, and it's not being used. You will still pay $20 no matter what. They can care less if you use it or not. Okay? That will be your initial value. So in other words, it's safe to say that your cell phone bill would always be at least $20. Initial value. Okay, so I want you to do the same for the next two questions. Now, for question 3, determine each rate of change. So you are given a bunch of graphs here. Okay. Journey. Let's take a look at journey of a motorcycle for a second. Now these we know are all linear relations because, well, they are all lines. Quick question, this is starting at 0. Is this a direct or a partial variation? Direct, you got it, because it's starting at 0. Okay. Now with that being said, it's asking for the rate of change. So what is it, how often is it changing? Well, let's take a look. At, let's pick any 2 points. Let's pick these 2 points, okay? And we simply just draw a triangle. And why do we draw a triangle? Because we're looking at the change in the distance over the change in time. So this is something called rise over run. Rise over run. Okay, so if we look at so the rate of change is equal to rise over run. So what's the rise? Well, if we take a look here, it's 240. So this is the rise, so this side of the triangle. What's the distance here? 240 minus 160, because we're looking at just this section, right? And that will give us 240 minus 160, okay, over, now you know what I should have done is use a different color for the run so you can see where the numbers are coming from. So let's use green for the run. R-U-N, okay, R-U-N. So the run, which would be the distance on the x-axis, well, what's the distance between 2 and 3? It's clearly 1, right? But let me just show you that it's 3 minus 2, okay? And there is your rate of change. 240 minus 160 will give us, where's that? Is it this color? You know what? It's good enough. 80 over 1, which means our rate of change is equal to 80 kilometers per 1 hour. That is our rate of change. Okay, and like I said, any other question, just post it on the forum or give me a shout in my email.